Hey guys, no BS, just let's get into the video. This is going to be my first video, and I know my channel is dedicated to DevOps. So I thought of starting out with virtualization. I'm sure a lot of you guys know about virtualization, but I just start out with this as it is a very important component when it comes to DevOps. And you'll have to know virtualization, what is a server, and why in the first place we need it. So yeah, just let's get into it. I mean, why did we even need virtualization in the first place? So, suppose you have a laptop that acts as a client, and you have a web browser where you enter google.com. All right, just click and you press enter. What happens? This goes as a request to the Google server. I'll come to servers. Just give me a minute. I'll just come to servers. Yeah. And the server responds with a HTML page as response to you, and you see the good old Google, this thing, search. You can do whatever you want here. So you get this, right? So how does it work internally? I'll just let you know. So if you see the server, so I'll just get into servers. What is a server? You have this laptop, right? This laptop can be made into a server. This is a physical hardware. This is already a server. Suppose you have a desktop, right? You have a desktop. This can be made into a server. So you can say server is something, it's a role which any device can play to serve as long as it's serving requests from any client. Right. So there are two types of servers, two types of servers. Right. Usually in data centers, you see one is rack server or rack mounted server. All right. Another you see is blade servers. Blade servers, or you can say chassis mounted servers. Usually it's referred as blade, but yeah. So what's the difference between them? In a rack server, you'll have a huge rack. It's like a cupboard type thing, and you'll have these servers, which are these physical boxes. It'll be just like this. You fit them into, there are slots in this huge rack, okay? There'll be slots like this. You will just fit them into slots, these slots, okay? You'll get all the power, cooling, everything inside this. As if I wanted to say, you'll have cooling for these rack servers in them itself because they'll have fans in this, they'll have everything inside this. So cooling will be done by the server itself. So the only disadvantage in this is it takes more space. So this is not how you see it. It's literally a huge box, right? This takes more space. And for every server, you need to connect it with separate wires, right? For network, for your power, you need separate wires. This is one disadvantage for this. But if you take blade servers, what happens is you have a chassis. Okay, this is a chassis, and there are blades. Okay, these are thin. These are thin, very thin. I'm not gonna put it this way. Let's put it this way. Yeah, these are blade-like servers. Okay, there are slots like this. You just put them in these slots, and these act like blade servers. At the end of the day, you'll have a huge rack. Suppose this section is for the rack servers, and here you'll have the chassis where you can fit this whole chassis into this. This will act like space for the blade servers. This is how it works in reality. All right. And this really takes up less space as compared to the rack servers. And suppose there is a problem in any of these blades, you can just take them out, just take them out and just put a new one. It's very easy to swap. There are external components which the chassis needs to support, like video cards, etc. These blades support some of the components like CPU, RAM, they have it in them, but like video cards and all, you put it in the chassis and you connect to the servers. You don't have to connect to that separately, just put them in the chassis. The server automatically detects the cards. All right. And suppose you have to give them internet. Now, what we usually do in rack services, we might connect a Ethernet here. That is how you give internet to the server. But in Blaze servers, you can just add a single cable to the chassis, and you'll all the Blaze servers will be having internet. There is no need of more cables. That's one big advantage which these Blade servers have. And combined, if you take all the servers combined, they give a huge throughput. So for high applications which need high processing power, you can of course go for the Blaze servers. All right, I'll just not go more into these servers and their types. Let me come back to why we needed virtualization, why these huge servers are not on which the single app resides nowadays. So during the old days, you have this huge rack. Suppose you have a rack, you have a r- rack server in this. Just imagine, okay, and this is that server. Now this server, I'll take it as this a logical diagram for the server. This server has some hardware in this. This is the hardware part. All right. And on top of the hardware is what the app resides. This is used to be during the old days when they did not have virtualization. They used to put a single app on top of a single physical server, and clients used to access this. But suppose there are 100 clients. Now, during a normal day, let us say 30 of them are accessing. But someday there might be like 10, there might be like 5. Right. In that case, the resources of this server go into waste because these servers they have a huge RAM and huge storage. So I have seen servers which have like 1.5 TB RAM and they have like 2.5 TB storage. I've seen these servers in real life. So this is when virtualization came into place. So there's a company named VMware. What they did was they released a software named VMware EXSI. So this is what? This is a hypervisor. The software is called a hypervisor. Hypervisor. Now, hypervisor are of two types. This is type 1 and there is type 2. In case of a type 1 hypervisor, we usually install this software into a bare metal server. So what is a bare metal server again? This is the bare metal server, the rack server or the blade server. These are bare metal servers. You install this hypervisor into this. So logically, the diagram would look like this now. And hypervisor is not OS. It is a separate thing. Suppose this is your hardware. This is hardware. This is the hypervisor. Hypervisor. Okay. What this allowed is to create multiple virtual machines on top of the same physical server. Virtual machines or VMs. These are the ones. You can spin up as many as you want until and unless the hardware is supporting. So now generally servers come with, they don't come with i7, i5, i3. They come with something called Intel Xeon. These are some server specific chips provided so that they can support high workloads. And what these virtual machines are, they are equivalent to a server. A single virtual machine can act as a single server. All right. So what hypervisor does it does two things. Hypervisor does two things. It allocates CPU, memory for all VMs, for all VMs. Plus, it also helps us create VMs in isolation. All right. This is what hypervisor does. It virtualizes the actual hardware to support a VM. Now see, VMs are what? They're logical things. They're not actual hardware, they're virtual. So they need to have some virtual RAM, virtual vCPUs and all. So these are created or allocated by the hypervisor. All right. Now if you consider a type 2 hypervisor, suppose take the type 2, this is generally installed in your local machines. Suppose you have a laptop. You can install this into the laptop. And now you can spin up VMs on top of your laptop, right? So how the logical diagram for this would be is you have the hardware here for the laptop, you have your OS most importantly, and then on top of this you have the hypervisor. Okay, it is installed on top of your OS, and now you can spin up VMs based on your hardware available in your laptop, right? This is the type 2 hypervisor. Yeah, for example, you can say Oracle VirtualBox. You can download it and you can try out using different images like Linux, Ubuntu, I mean Linux, then Windows, Unix, and all. All images you can try out spinning up VMs, and it would work perfectly good, right? So nowadays, what we see is we don't see apps running on top of VMs. We see apps we see apps running in containers. Now I'll make a whole separate video for containers because this is a very important topic as far as DevOps is considered. So I'll make a whole different video. But in real life, suppose you have youtube.com. This is hosted on top of a container. This runs on top of a container, not a VM. This is not what you see in YouTube. And containers, they run on top of VMs. That is how it works. You have a VM here, suppose there is a container, there's a pod in this. There's a pod which is a most smallest abstraction as far as DevOps is considered. It's called the smallest deployable unit, to be honest. And on top of this pod, inside this pod, there are containers which run. Right, this is a container, and the app runs inside the container. And in real life scenarios, a pod can support multiple containers, but it's generally only one container in a pod, right? So I'll make a different video about containers, and I think, yeah, that was all about virtualization. Thank you all for listening. See you next time. Bye.